Okay, so we're going to get started. This is data storytelling with R from the Commerce Data Service, provided by the Commerce Data Service. For people in person attending, our lovely analyst in the back, Anne-Marie, she has a microphone, so if you have a question, please raise your hand. She will bring the mic around so you can ask it. For people on WebEx, we have a person attending the WebEx in chat, so if you have a question, just ask it in chat, and then we will answer it on the screen. Yeah, other than that, the recording of this and the notes of this will be posted as soon as we get them. We will send an email out for all the attendees at that point. And there were questions about the last class, data analysis with R. There was a mix-up with the recording. We are still in the process of processing that. So the minute we have that, we will send it out to all the people who were in that class. Okay. So without delay, let's get started. This is data storytelling with R. And the presenters are, my name is Ying. I'm a data scientist here at Department of Commerce. And co-teaching this class is Chen, who is the chief data scientist at Department of Commerce. So we work as part of the Commerce Data Service that is providing this class. So just a brief outline of what we'll cover today. A brief refresher and background for people who may have forgotten anything that's covered in the Intro to R or Data Analysis to R class. Sort of a background on what data analysis, data storytelling is. And then we'll cover some of the packages that we think may be useful for your efforts in data storytelling. So just a brief opener. R, if people don't remember, is a free environment for statistical computing and graphics. What makes it special is it's an object-oriented programming language. It has more than 6,000 packages, which is additional capabilities that you can add on to R. And it compares very favorably to other traditional statistical packages that you use, such as SAS, Minitab, SPSS. And also, we're also going to be demoing our code today in R Studio, which is a free user interface for R. What makes R Studio so good is that it includes a console, an editor, an area to see your object environment, and plots and all those things. It's a very nice, cohesive package for R programming. So hopefully for those following us along, you will have both R and R Studio already installed on your computers with the packages we listed before. If not, you can follow along after class. We will post the slides and the recording as soon as we have it. So a brief refresher. The first line we have here, in R, a comment is prefaced by a hashtag, a pound. We assign a variable by using the left arrow. We can concatenate, combine things as C parentheses, things together. We can create a matrix, a 2D matrix, by the following command, matrix of the entries, and specifying how many columns and rows there are. And we can make a data frame, which is a list of different types of objects by the following command, a data frame of each object, so on. So this is just a brief overview. For people who maybe need a more in-depth brush up with R, they can please refer to the Intro to R class or the Data Analysis to R class. Okay, so just a little background. This class is about data storytelling in R. So before we get to the R portion of that, let's cover a little bit about what encompasses data storytelling. So when we talk about data storytelling, we're primarily talking about how it differs from data analysis. So when we think about the two, there are clear differences, right? One sort of comes at the end of your process, the other is the process. So if we think about data storytelling, what it actually is, when we talk about it, it's about presenting your work and results to your client, to the person you're doing all this for. It's about hopefully leading them to a decision or action from your analysis, that some conclusion you've made. It should focus on your client. It should be geared towards your client. The polish of it, the how refined you've made this data storytelling should be high. You should have gone over it many times. Your visualizations, your content, your narrative, all of that should be highly polished. And you should be aware that all your data storytelling should be subject to external review. So this is something that you, whether implicitly or explicitly, should be prepared to be public for people to read. Whether that be public in the sense of other government employees, to your supervisor, to the general public in the federal sense, that could all be it. But it should be subject to public external review. And so that differs from traditional data analysis in the following ways. So when we think about data analysis, what we're really thinking about is how we do our process in our analysis. How do we make it faster, right? How do we analyze the data set or the problem we have? It's geared and focused on analysis and modeling. So traditionally, when we do data analysis, if people have taken data analysis in our class, it's about how we clean the data, how we process the data, how we model the data, how we come to a conclusion. That's the whole pipeline. And then when we're doing that with ourselves in mind, with our team in mind, or with the researcher in mind, right? And because this is something that's a work in progress, the things we generate from that are usually very low levels of polish. They're not something that we typically are very highly visually arresting. They're not, they're sort of very raw, very first pass things, because they're used internally for us to gauge what we're doing. They're not meant for people outside of the team or outside of the researchers to see, right? And because when we do this stuff, we don't anticipate all the nitty-gritty that we're doing to be released to the public, right? Because, well, in all honesty, most of them wouldn't care, right? If you're not gonna give all the things you did to your clients, right? You're gonna give them what is actually applicable. So those are sort of the brief differences between sort of what we talk about when we say data storytelling and what we talk about when we say data analysis. So just to focus on data storytelling, we sort of break it into 3 buckets. The first being content, being what is the content we want to convey to our client. And when I say client, it's very general. It can be your supervisor. It can be an actual client that's contracted you. It could be the general public. It could be the secretary. It's whoever has sort of is the last person you have to do this report to, who you are making this report to, who you are making this final conclusion or all this analysis for. That's the client. So the content is what we're actually giving them, the actual, the action, the policy, or whatever it is. The next bucket is sort of the visualization. How do we visualize that? How do we make it easier for them to consume that, to internalize that knowledge that we've spent so much time developing? And finally, we sort of want interactivity, right? Because we want people to buy into our analysis. So the ability for them to interact with our content, our visualizations, makes it better. So when we talk about data storytelling, those are sort of 3 buckets we want to think about: the content, the visualization, and then the interactivity. So just a little focus on the content. Right? And we can think about content as what we're transmitting outside ourselves, outside our team, outside our internal agency, outside of anything, right? Outside of our core work group, that's what we're transmitting outside of. And so when we think about content, sort of some bullet points that we want to think about. What is it that we want to focus on, right? We want to focus on the main takeaway we want to give our clients. What is the big final conclusion? What is the executive summary that we're going to convey? That's what we want to focus our content on. We should consider the audience's perspective, right? So you as a researcher may think, heteroscedasticity is very important. But if it's not applicable to your client who's doing business and all they want to know is, can we ship to Albania or something? They don't care. If it doesn't affect their analysis, they don't want to know. you should limit, again, the technical details of your analysis to the skill level of your audience, right? You don't want to blow them over the head. You don't want to knock them out with all the technical details of your analysis. Say you've done some very intricate and highly expensive machine learning algorithm, and it's super complicated and it's super impressive. You have Amazon instances, you have giant server racks crunching for hours and hours, days on end, right? But even if you did all that and it gets you the answer, you don't want to convey all the minute details of that to your client. They don't need to know that, right? You need to be able to consider what is the skill level your client needs to know this by, and you want to tailor your message to that. Something else you should also be aware of is that with data analysis, with statistical modeling, there are always assumptions that we make, right? You need to be very conscious of those as a data scientist or in the field of data science. In your content, you should always highlight those assumptions because those are the things that will sink your analysis, sink your conclusion if they are false. So you should always make sure to highlight them and convey them very clearly to your clients. One of the things that I also want to remind people is that typically a lot of people think, well, I did so much work in my analysis. Like I did so many methods, I spent so much time cleaning the data. And I spent all these contract hours or all these work hours. How do I justify that? And a lot of the tendency to compensate for that is to put all of it into the content, right? To put everything you did there to make sure it shows on the page, and that ends up harming the message. Ultimately, what you want to do is not cover everything you did, cover only the things that directly led to the final conclusion, the final takeaway. And you should order that content such that it flows from the audience's perspective, from your client's perspective, and not from your sort of what you did chronologically. Because it may go out of order, right? You may have done some data cleaning and say ran a regression on it. And notice that like, well, this doesn't quite work. I need to go back and clean the data some other way. Well, you should order it such that it makes sense for your client that you should just clean the data, do it the method that ultimately you chose, and then the final conclusion. So that's a brief example of content, like how you should order your content. So the next thing we want to talk about is visualization. That's sort of how we conceptualize all the content we had to the clients, and sort of what we want to keep in mind when we're doing visualizations in data storytelling. And so you'll find in R and in Python or and pretty much every popular language you program in that there's so many packages that can create a whole host of visualizations for you from your data, from your analysis. You can even in Excel, you can build so many charts, so many tables, right, that you can overwhelm a report or anything you do, right? And it's very easy for you to say, well, if I have more pictures, that means I did more. But really, what you want to do is limit your visualizations to the core message and make it only so that the things that are super important to your takeaway should be there. So when you're building these, the thing to keep in mind is to think about how your visualization relates to your analysis. So it should only, if the inclusion of it helps clarify some component of your analysis, then it should be included. If it doesn't, if it makes it worse, if it leads to other questions, you should keep it away. Because that's not ultimately what you're telling the story about. So again, sort of coming off that, every visualization you make should reinforce your takeaway, your main conclusion to your client. And it should be ordered in the way you ordered your content, right? How many times have you read a report such that this visualization comes at the end or not with the section you are reading? So you have to like flip pages where you have to like scroll down or back up. It's not where in the space where you want it to be. So it should always be that way. And the thing I always tell people is that you should use visualizations to control the tempo that you read your content through. So what that means is you should use it as almost like a punctuation mark. right? It should be sort of a period to a section, or it should be an exclamation point to an important specific analysis or component. It should be a final declarative sentence, if that's what it is. You should use it as a punctuation in that way for your whole data storytelling. So the other thing that you should be aware of is that your data storytelling object or entity as a whole is one thing. Even though you're building it piecemeal, your client receives it as one thing. So everything in that object should be stylistically cohesive. How many times have you gotten, say, a visualization like a bar graph that's like colored in like red, and then the next one is like green or magenta? You know, like it's all over the place. Like the font's different, everything's different. Those are little finishing touches that you should make to your visualizations to make them cohesive. You should make sure all those things match and are sort of like reinforce each other. Okay. So the next thing I want to talk about, which is the last bucket, is sort of interactivity. And that's sort of a newer thing that a lot of people are more interested in, sort of the advent of JavaScript and HTML and like, you know, all these things like dashes and like dashboarding, Tableau, you know, like you probably all heard those terms. Like it's sort of the forefront of where visualization is. And what interactivity gets you is that by allowing your client to look and actually interact with some part of the data, some part of your analysis, it allows them to understand it in a deeper level. It allows them to comprehend it in a deeper level. So when we build interactive visualizations, the idea is that we want to compromise, we want to balance it between something that is highly visually arresting, highly super flashy, and something that's actually actionable. So like that maps to policy decisions or actions that your client will do. And so that leads to this thing that commonly happens is that there's a lot of software packages now that add dashboarding as a feature. You can build all these dashes and all these mini graphs and small multiples of things, and they just sort of spit out sort of summary statistics. They don't tell you anything. They don't tell the client, well, okay, so what if, you know, 30% of my traffic on my website comes from Georgia? What does that tell me? What should I do about that? Right? If it doesn't tell me, if it doesn't map to something, it shouldn't be there. Don't include it. Right? So that's the thing, is that you should be aware that dashboarding and building dashboards should not mirror exploratory data analysis with data touch, right? It shouldn't be about summary statistics. What it should be about is it should clarify questions your client has. It should never compound them. Like the fact that they can interact with that visualization should not make them more confused about what you're doing. They should make it more clear. And so you can often think about, as you're building these visualizations, that you can sort of click in, zoom in, pan out, sort of like put all this stuff in there. And in the same way that, traditionally before you could build so many charts, you could build so many static visualizations. Now, in a single visualization, you can put in so much interactivity into it that it can overwhelm the person, right? You could do so much in there that there's just so much noise in there. You've added so much to that visualization that they can't take anything out of it. It takes them too long to get into it. So you should be careful not to overwhelm your clients. And again, these are still visualizations, so they should still reinforce your main takeaway. They should reinforce your conclusion. And again, because they are visualizations, they need to be stylistically cohesive across the board. Okay. Again, if there are any questions, feel free to raise your hand if you're in person, or ask it in WebEx, and I will try my best to answer. So with the background out of the way, we're going to cover ggplot2, and that was covered before in Intro to R, and I believe data analysis to R. So it's a brief overview. I'm going to go over a few examples of how to process sort of a time series data and plot it in ggplot2. Sort of what makes ggplot2 So Awesome is that it has a very simple API versus the traditional R graphics API. A lot of people in data analysis use ggplot2. So typically, it's used in the data analysis portion before, if you think about it, and not in the data storytelling. But it can be used in data storytelling. You just have to format it all, you have to make sure all that stuff looks nice. So it's very easy. You can also use it as a way to sort of wireframe your interactive visualization. So say you have a time series that you want to build an interactive plot on, a graph on, right? It's very easy in ggplot2 to just test that out, see how it looks in a static visualization before you actually have to implement it in an interactive visualization. So that's sort of how I envision using ggplot2. So for those, hopefully you've installed ggplot2. If you haven't, this is the command: install packages ggplot2. And to load it, you do library ggplot2, no quotation marks. And we're going to use an example that comes with ggplot2, which is economics long. You can check if it loaded correctly if you do this command, head economics long, and it should come up with the first, I believe, 10 observations or rows of economics long. We can check right now. Let me do it right here. So we load ggplot2, and we do head of economics long. And it's the top 6 rows of that data set. So hopefully everybody who's installed ggplot2 should have that on their screen right now in RStudio. Okay. So just a brief overview or review again. To create a ggplot area and add a very specific geometric object onto it is very simple. You call the ggplot function, and you supply it the data you're going to pass it, and then all the aesthetic options you want for it. What is X? What is Y? What is the color? What is the group? And then you add sort of what is the geometric object you want to plot. Is it a point? Is it a line? Is it an AB line? And so on and so on. So you can refer to the ggplot2 website, and it'll list all the specific types of graphs it can do. I won't go over all of them. We're just going to go over points and lines today. So with our economics long data set, we can try and plot out all the variables, see what happens. And so the next line will show you a time series of all of them across the board. So let's see if we can do this. Can I copy? See if I can copy this. And do GG. That won't work. Okay, and hopefully this doesn't error out. And we get this. So hopefully everybody should get something similar to this. And you'll see all the variables within economics long data set. And it's just a time series by date. I believe PCE is consumer expenditure, POP is population, PSA is the savings rate, unemployment, med is the like medical insurance coverage, and then unemployment is just the unemployment rate. So you can see how those relate to each other in a time series. Okay. So what if we want area contours instead? It's very simple. We just change one thing, and we tell ggplot that we don't want a line. Instead, we want, I believe it's area. So if we just change one very small thing, the plot changes how it's plotted. So let's see what happens if we substitute line with area, and we get something like this. what's the question? My question.
We have a question. What does group do here, or in general? When I ran it without group, I got the same plot.
So group defines what variables are grouped together. So that's what's the variable that we look at to define what are the all the variables within the plot. So it may be that ggplot takes care of that on its own because of the way the data set is structured. But typically you want to specify it. Okay. So there are more options. You can pick them. Well, let's try something else. What if we just want points? I believe if we do g on points, we get just a scatter plot of it. So I'll leave it up to you to explore all the different options. You can go to the ggplot2 website and figure it out. This is meant to just be a brief overview of this. So you might have noticed that economics long is like very specially formatted to feed into ggplot2 as a time series. So what if we have our own time series data that's tabular, that has the date plus our observation for different variables in columns? How do we make that into the same form to feed into ggplot2 so that it makes it easy? And so the easy way to do it is to use a package called reshape2. So if you don't have that installed, the command is install packages reshape2. And to load it is to just call library reshape2. So what that does is reshape2 has a command called melt. And that actually takes a traditional data frame with columns and rows and converts that into long form. So it stacks all the dates for every variable in one single long form, and it just labels each entry as the variable it was pulled from. So let's try that ourselves. So we're in luck that economics, not economics long, is the original data set, tabular. So it has a column called date, and it has all the variables that we just plotted as columns, right? So how would we feed this, convert this into a form that is economics long? So if we look at economics long, what they've done is they've taken the date, they've taken the value for each of the entries for each column, and they've labeled each of those entries as what variable it is. So that's a long form of it. So reshape2 has the melt command allows you to reshape it from tabular form into long form. So we can try that. So the command is melt the data set we want, which is economics, and the variables we want. So we're just going to take the date and let's say the savings rate, which is the fourth column. And I believe this should work. Oh, I didn't import the library. Shape2. Let's try that again. Let's just tie the top of it so we get a feeling of it. Oh, okay. Sorry, my mistake. So we have to specify melt. What is the date variable? So it is date. Let's see. What am I typing wrong? Yep. This one? So I must have a typo somewhere. Let me copy and paste it. Huh? Right. It should work for all of them because we can take any one we want. Let me try this and just paste it in. No, so there are two data sets. So economics long is already formatted in economics. into the long form. So is it because it's a vector or it's a data frame? No. Huh. This worked last night, so maybe I have a typo somewhere that I'm not catching. Yeah, there. Yeah. Huh. I don't know what I'm missing. Does it work for you? So let's see. That works. Let's try. So connect or set closure to vector of type any. Yeah. I don't know what's happening, but no idea. Well, these things happen. So I will figure that out some other time. Let's just move on, I guess. There's a typo somewhere, but I will fix it. Typically, this is what you do. You use the melt command to create a long form of the data set. And what that will do is it'll produce basically what economics long is and allow you to plot it. So, okay, so I had actually asked people to do the exercise, so let's all do this together and figure this out. So let's work on this together, and maybe we can figure out what is happening. So let's take about 3 minutes. No, so I'm trying to think of what happened, because last night it totally did work. Huh?
Someone suggested quotes. Yeah.
Oh, is that what it is? Okay, my bad. Okay, so that's the typo, is that there are quotation marks. Okay, I must have missed that. So let's fix that. That you have to quote the variable that you want to preserve. Interesting. So let's work through this exercise together. We can reshape basically any variable in our economics data set and put it into long form to plot into ggplot2. So let's try. Let's call it economics melt as melting economics C. Let's try the fifth variable, which I believe is saving rate, or the unemployment, and quotation marks date, and that'll assign a new variable, and let's plot that to ggplot. So we want to pass it the data, which is economics melt. We want to submit the aesthetics believe it's X is date, Y is value. Say color is a variable, because we want to color everything in the variable the same, and let's add it as a line. One second. Am I misspelling that? Oh, underscore. GM1. And we get that. I'm sorry, can you say that into the mic, please?
Well, what's the difference between economics and economics melt?
So melt is just converting it into long form that feeds it into ggplot.
What do you mean by long form?
So long form is like I showed you before. So let me show you. Economics long is that same data set in long form. And long form is saying when we don't have columns, every single observation is its own row. Well, instead we've done is labeled each observation by what that observation is. So you'll see there's a column called variable that's saying, well, for PCE we observed 507 on 1967-71. So that same entry is in economics, but it is in a column by itself. So long form is stacking that in a single long form. So like making all those single entries one single row. Is that clear? Yes. So it's about formatting your data to feed into ggplot2 such that it allows for a nice visualization in time series. Can you say it in the microphone? I'm sorry.
So in economics, there's some rows that say POP and some rows that say PCE? Or no?
It's in the columns for economics. So let me pull that up. So you'll see here, each column has a different name: POP, PCE, PS, PSave rates, unemployment med, and unemployment, right? So that's in tabular form, commonly called tabular form, right? We have a matrix of them, right? Every column is a specific feature we've measured, and every row is an observation, right? In long form, we don't do that because it's a time series. We stack each one by specific, each observation as a single row. So if we do long, you'll see that first PCE 507 is its own entry. Right, we do that for every single variable. If we go all the way down, economics long.
So the date repeats on another row, the same date?
Yes, so it's the combination of date variable that is unique. It is not just the date that is unique. Yeah. It's the combination of every variable by every date. That's long form. Is that clear? No. Yeah, question? I'm sorry, because since we're recording this, can you speak into the microphone?
Yeah, I keep getting that the melt function couldn't find the melt function, and I feel like
did you install Reshape 2?
Mm-hmm.
So did you import it, library Reshape 2? So this is just a way of showing how to convert things into long form to feed into a time series visualization.
Okay, so it seems that with what we've been practicing, we do the one variable. So, but when we did the graphing before, we had multiple variables in long form. So how would we convert that table to have the multiple variables?
So we can pass more than just 2 variables. That's all we've been doing. We can pass more. So let's pass the 4th and 5th row, 5th column, and that'll give us 2, right?
So if you wanted all of them, you would just include
pass the whole
all
thing.
columns in that.
Yeah, so we wouldn't subset
concatenate.
it. Okay. Right, and so let's graph that one. And we got 2. Yes. Because it labels each observation by what variable it was measured as. So it's a combination of variable by date observed. That's the long form.
We have a question from Steve Finkelstein, who is also a detailee with the Commerce Data Service. How much does melting a data set impact performance? Is best practice to only use the melt function on smaller data sets?
So for most time series, it shouldn't be that intensive. The cost will not be that high. It's already as optimized as it could be because it's from the Reshape 2 package, which is highly mature. Typically, that's why you want to subset your time series to the ones you want. You don't want to pass the entire data set unless you're only interested in the entire data set. Any other questions? Okay. So that was just a brief overview of how to do a time series in ggplot2, how to reshape your own data that's typically in tabular form with columns and rows into something that resembles a long form. Okay. So we did that exercise together. We can do any one of those variables and plot it. So let's move on to another package, or actually, before I get ahead of myself, let's do a 10-minute break, coffee and bathroom break, and then we'll reconvene at 1:54 Eastern Time. Okay. So there's really only 2 commands that we use, which is this one, the first one, and then the second one, which is the plot. Okay, so 10-minute break, reconvene at 1:54, sorry, Eastern. So we'll pick up in a few seconds. Okay, so after that brief overview of ggplot2, let's get into sort of some of the interactive packages that would help you in your data storytelling. And one of them I think is very useful in presenting the raw data or your clean data is a package called data tables. We've asked you to install it. It's DT. So what data tables does is it presents your data set in the tabular form as searchable and paginated. So you'll see in a second what that means. What is this used for? If you want to present your raw data as a starting point in your data storytelling, something that you've cleaned already for your client to examine, if you want to convey sort of the magnitude of your data, the shape of your data, if you want to allow for your client who has more knowledge, hopefully, about what that data is than you to sort of connect to that, to give you useful feedback on it. This is a way to do that. And it's useful in discussing specific cases, such as outliers or specific examples that you want to point out within the raw data. So the way to install the package, if you haven't done so already, is install.packages quotation marks DT, capital. Capitalization is important. And to load it is the library DT. So this is actually a very straightforward package, and you'll see in a sec. I'll give everybody a few seconds to load it if they haven't. The way to call it is here, and that looks like a lot of options. You don't really need to know most of them unless you're formatting the data again in a specific way. So the call is data table, the data, an option in list form. You can see what all the options are from the API yourself. You can pass it the row name, the column names, the container name, a caption, and if you want a filter. So let's just do a simple example. Let's see here, data table economics, see what we get. So let's call the library, and let's just pass it economics, the data set we were using before, and see what we get. And so if I make this bigger, you'll see here, I don't know why that's happening. So here we have 10 entries on each page of every row of that data set. It has all the variables. It's just paginated like you see in a table on an HTML, like on a website. Paginated means it's split it into multiple pages. So we can actually interact and click on multiple pages of each observation. We can search for specific values and it'll subset it. So say we want only observations in 2014, or only things with 2014 in it. Apparently there's 2014 in here for pop, and it'll give us all the rows with 2014 in them. We can do that. We can clear it, and we can reorder the data, sort it, and this is all comes as part of the data tables package as default. So say there's a lot of options. I'm just going to cover one other one. You can look into more of them. So say we want more results per page. You can change that here, or you can specify a specific amount within options. So the way to do that is to specify in options a list, and I believe it's called, well, let's just check so I don't make a mistake. Page length equals, say a really weird number like 33. And what you'll see is for each page now, why is it 10? Try The size thing. Okay. Sod. Okay. It should work. I don't know. It might be something with the formatting, but it should change all the options. The number listed to 50. Let's check if I. Oh, is it capital L? Okay. There we go. There we go. So capital L. Another typo. Let's fix that. So what I always do is just check the function and see what options we can take in the options. And so you can click on this website and it'll tell you all the options you can pass it. So it'll give you the number. There's way more options. We have a question. Can you speak into them? I'm sorry, we're recording this, so you need to speak into the mic.
Why did you put a question mark there?
So question mark, if you were in the intro to R or the analysis to R, question mark just pulls up the help page for a function. So if you're ever unfamiliar with it, you just do question mark the function you're trying to pass, and it'll show up the help page for it. So if I do that again, I get the help page for data tables. And so that'll let me look up all the options I'm passing and what I'm doing wrong. Okay. So it's a very simple, very straightforward package that allows you to present something in tabular form to your client, just row by row, the raw data that you've cleaned. And so that's just an easy way to do that. So we'll just move on to the next package that I'll cover today, and that is Digraph. For people who've worked in JavaScript or HTML, Digraphs is a very popular JavaScript library to visualize time series. This is essentially a R layer interface that calls that JavaScript and renders it. So you don't have to know any JavaScript to plot it. So Digraph is specifically built for time series data. And what it does is you want to pass it XTS time series objects, and we can get into that more. XTS is a very specific format for time series objects in R, and it's useful in help visualizing very long time series. So if you have a lot of it that you want to visualize, or a streaming amount, a continuously updating one. So two packages that we need. Digraphs, which is the package that will plot it, and XTS to make sure we can format our data into an XTS format. So the commands to install those are install.packages digraphs and install.packages XTS. To load those libraries, the same thing, library digraphs and library XTS. Okay. Hopefully everybody has them. If not, you can always try and install them now. So we're just going to cover how we would pass our data format it into an XTS form. So to convert a data frame in R to XTS, the command is very simple. It's very straightforward. It's XTS, the data you want to pass, and then what you want to order the data by, essentially the date or the time stamp that you want to order it by. So it only takes two variables. That's the thing you should remember. It only takes the value that you're measuring, and it takes the timestamp that you're measuring it by. The function to pass that to a digraph is digraph, the data, which is an XTS object. And you can pass it all these additional options, which is the main, which is the main title, the X label, the Y label, if it has periodicity, if you want to group it in a specific way, the width or the height of your visualization. And so you can look into how to do all those things on the help page or on the website for Digraphs. It'll go into it more deeply. So let's try and again use our economics data set and see if we can convert it into an XTS format. So first thing we need to do is create a variable that is in the form of a date. So if we look at economics and the first column, which is the date, it is typically, you'll notice it's not actually in date format, it's actually a string that looks like a date. And so what we want to do is format it into a date. And the command to do that is in R, you don't need to load a library, it's as dot capital date economics of that first column, and we're formatting it, we're telling it what format that string is in to return and parse it. So let's try that. Hopefully that should work. Yes. Now let's just take a look at what date me says. And it's all these dates in date format in R. So it looks essentially the same, but what's different is it's formatted the underlying type has changed from string to date. So the next step after that we want to do is we want to bind it to the variable we want plotted. So we can pick any one of those from economics data set. Here in the example, we take 2. So let's try to bind it to economics 2, which is, let's see, what is economics 2? Which is the PCE, the consumer expenditure. So let's do that, which is, what did I call it? Value me. As we attach, cbind is column bind, so we want to bind these 2 vectors as columns. Date me and economics. The second column as the vector. And that should work. Yep. So if we look at that now, we get something like this. And so you notice the date has really changed because it's in the universal format. It hasn't formatted it doesn't layer the format of the date on top of it. And so to convert, we pass that to the XTS function, and the command to do that is XTS, the variable we just made, and we pass it what we want ordered by, basically the timestamp. So we want to plot me as XTS of value me order period by value me, comma 1. And hopefully that should work. Oh, I haven't imported. Let's try that again after we've done this. Appropriate time base out. Okay. So minor typo. So we need it as a data frame because it restructured the value. So this is actually, we can't bind the vectors. We need to bind different types of objects. So it's data.frame. Did it work for you? I don't know why I got the error then. Maybe it worked for me last night. But this works. So the date and then the value, and then we pass it over, and it gets the plot me. So that has the XTS format, and let's just look at it to see what it looks like. And so that should get you basically what we're after. So let's now, once we've formatted it into XTS format, we can pass it to digraph, and that calls are actually really simple. It's just digraph of the variable we've made, the XTS variable. We should import that first. So library digraphs and digraphs of plot me. And so it looks just like a regular time series, but it's actually rendered in JavaScript. And you'll see we can subset it. We can highlight a specific area, and it'll show us the value and time of it. And so on. There are a lot of options for digraph, and you can pass it something. One of them is a range selector, so let's do that. And all you do is you add this as an additional option to it. So it's percent greater than percent believe I range selector. And let's try that again. And what we get is essentially a range at the bottom that we can drag by. Okay. So
I have a question.
Yeah.
Could you please say again, as you go through the different steps of changing the data set, you did as date and data table and XTS. Could you please say again what you're doing in each of those steps and why you need to do that?
Okay. So I'm covering a couple packages. So data tables is just a library in R that allows you to present your tabular data in basically an HTML table. Right, so it's interactive for the user. You can search on it, you can customize it in the way you can customize an HTML table. So you can embed that, and later on we'll show you how you can embed that into a cohesive single file or report. But right now I'm just showing you how to call each of those. So for data tables, that allows you to do that. And digraph allows you to plot time series data in a very natural way. As you'll see here, there's a lot of options. It's suited for time series data. And you can add things like a range selector on the bottom. And this is all interactive, and we can drag and drop and drag everything, and we can highlight specific observations. And so, but the problem with digraph is it only takes objects that are formatted in XTS format. So I was just covering how to convert objects into XTS. Is that clear? Okay. So the problem with digraph is that it only takes, for each time series that you plot, it is a single XTS object. So you have to make multiple for multiple ones you're plotting. So let's try another one. If we want two time series on the same graph, we would have to call it something else. So let's call it value me again. And this time we're passing 6. Okay. And now we convert this new date value pair into an XTS object again. And we call it something else. Let's call it plot me again. And we order it the same way we did before. Okay. Now, if we want to plot both of them in digraphs, we do, I believe, digraph cbind of the first one, which is our original plot me, and our second one, which is plot me again, and we get both on the same graph. So that's the way. It does not take, you cannot pass it multiple time series with one single timestamp. You have to make a new one for each time series. Questions?
Sorry, that didn't answer my question completely. I understand that you have to use XTS in order to make something viewable in digraphs, but in each of the steps, when you made date me, value me, and plot me, how are you changing the economics data set?
Oh, okay. So I can go over that here. Date me converts. If you look in economics, the date is just a string. It's just letters, right? And what we're doing is we're converting that into a date in R. So it looks the same, but underlying that in R, it is a date now. Now, when we pass a value me, we're adding to that new date variable the values we want to plot on the time series, right? And then in plot me, what we're doing is we're saying we have that value date pair that we just made in value me, and we're converting that into a XTS format object to pass a digraph. Is that clear? So so that's the difference. So if it's comma 2, you can use data frame because it's 2 different types. If it is just 2, you can use cbind. So it's just a question of the data types. And so that's probably why yours worked. Yeah, question? Sorry, if you could hold for the microphone.
Could you go over one more time what XTS was?
I'm sorry, say that again?
Could you go over one more time what XTS does?
So XTS is a specific format of a time series, and that's what digraph takes in to plot. So we format our data into an XTS format so that digraph can interpret it, right? And so to do that in R is very simple. There's just a function that does it. And an XTS format is a value and a timestamp pair. So you just have a specific value for a specific timestamp. So it needs both of those things. And so just going over, digraph, you cannot add an additional value to that pair. You have to introduce a new pair again if you want multiple time series plotted together. Any other questions? Okay. With that, we're going to, a question. Yeah, sorry. Let's go back.
Okay, so I just spent a long time trying to figure out some errors that were in mine, and I probably missed your explanation of this, but the 3 pieces of code that you had on slide 33, what do those pieces, like how do you know to put %y minus %m?
Oh, okay.
Like what are those pieces?
So that's actually, so I'll cover both. So like what are the three pieces and what is %y, %m, and so on. So if we go in R and we do question mark as dot date, index class for in base. So you'll see in the base as dot date package, there's a format. You have to pass it the data you're passing as a string, and then the format that string should be formatted into a date. And you'll see here, there's a whole list of them. It's not in the help page, but yeah. Let's see, isn't this time? Yes. So it's these observations. It points to another help page that has the same formatting. So %y, if we go down to %y, you'll see here, let me get to %y. So %Y is the year with century. So if we look at head of economics, you'll see the string is the year with the century, 1967. And then the month, right? 2-digit month, and that's %m, lowercase, which is month as a decimal number, with 0, 1 to 12. And then %, I believe, d, which is the day as a 2-digit number, lowercase. So day of month as decimal number. So that's what we're passing to it. So you'll see here, we're telling it what the string is formatted as. So that's how it can interpret it into a date format. Right? And I'm sorry? So when you did question mark as dot date, right? Did you get this? And so what that means is that they found two functions of as dot date. The one we're using is in the base library. So do date conversion functions to and from character. So that's the one we're using, right? We have a string of characters and we're converting it to a date. And yep. And so that lists the help. It doesn't actually list all the formats. You have to click on this string p time because it's the same arguments, so they don't list it twice. So if you click on that and you go down, you'll see all the different possible types for time, to, and as, and date. I'm sorry, can you speak in the mic? Sorry.
So I've done this like 10 times, and when I say head, plot me, it looks right. It has the columns with the dates and a date me column. And it has a TCE column. But when I graph it, the graph just has on the y-axis from 0 to 1, and on the x-axis it says 1900, 19:00. So there's no data that appears.
Huh. I'm not sure what is causing that. Is your maybe in the next break we can
Sure.
I'll come over and take a look because I'm not exactly sure what's wrong with your data. It's obviously an XDS format or it would error out, but maybe it's misformatted in some way. I have no idea.
Okay.
Any other questions from WebEx? Hopefully that's clear for everybody. It's just a way of converting things to XDS to pass to Digraph. And that gets you a very nice interactive visualization. Okay. With that, I'll pass it over to Jeff, who will talk about the second half of some of the more complicated libraries that we can call in R to make interactive visualizations. If you'll just bear with us for a second while he shares his screen and I stop sharing mine. Can you share your screen? Bear with us for a second. Hold on. Okay.
Yay. Good afternoon. How's everyone doing? Great. Well, thank you for joining us. We have a good showing of folks, both via WebEx and in person. So a total of 110 people have joined us so far today. We're very much appreciative for your interest in using R for bettering the good work here at Commerce. So today I'm going to talk through more three-dimensional work. It's very rare that analysis, storytelling takes on one or two dimensions. There are a lot of factors that play into everything we do with data, how we interpret it, the context that goes behind it. And so just for example, we look at socioeconomic status. That's comprised of many factors like poverty status, education, employment, income, like you name it, like it feeds into that. And when we start to think about these three factors and how they can be put together to see different patterns, we can see that there's some higher dimensionality. Like, it's not about just a scatter plot. There may be some hidden gems in projecting your data into 3D space. So today we're going to use a little bit of a modified data set from the American Community Survey, county level data, and we're going to extract some high dimensional insight. We're going to create some visualizations, 3D visualizations that are remarkably versatile. They allow you to explore information a little bit more. You can provide a headliner story, but then oftentimes to get more engagement behind your work, it's really useful for a user to be able to explore that information in a way that makes sense to them, or to look at different views. So to start, I just want to check if everyone has downloaded a zip file that was included in an email that Pam Mulder sent out. No? Okay. Well, if we could, you could also go to github.com/dataservice. And there's, if you go to CDA storytelling, I'm just going to it might just make sense to, paste. What have I done here? Get the class materials from here. And I'm just going to paste this into, well, yeah, you can get it after, or just check your email for that data set.
We'll send out an email with the additional data set if you haven't had it already. You can follow along after class if you don't have it right now.
So basically, I'm assuming that we have this data set, and you have you have a folder that contains it. So on my desktop, it's just class_materials. And just to start off, we're going to just set the working directory, so we can just work off of it. So if you can find the path to that data set, to that set of data, it's unzipped, that folder. We're going to work off of that. And within that working directory, and while you're sorting that out, I've named the data set something very basic, which is just base_file. And it's a CSV file, and we're just going to read it in. So going back here, I'm going to run the set working directory file, and then I'm going to type in the command read.csv, and then base_file.csv.
Is that better?
How about now? Okay. So read.csv base underscore file. And then we're just going to take a quick look at it. So when we use this call names, C-O-L-N-A-M-E-S function, just to pull up the column headers. And we have 10 columns. We're also going to just pull up the first 5 records. So we're going to run the head. Oh, well, that would have been looked a little bigger, smaller. But basically, we have something called state FIPS. This is a state ID that is standard for federal data. A regional ID, which is a census data indicator. A region name is the corresponding region description for that region number. Some fun, unsightly looking fields, ID and ID2. These denote which county these data points correspond to. Geography, which is the name of the county and state. And then we get to the things that we're really quite interested in. So house, PCT, poverty, so percent poverty rate. EMP status is the unemployment rate. And then HS grad is the high school, the graduation rate for high school and above. Cool. So we're going to now start to think about how to use this information. So we have some basic data points. It's been processed already. We're not going to really worry too much about all the data manipulation. So we're going to take that information and use something called three.js. Three.js or three.js is a JavaScript library that is designed to create 3D environments for visuals, really for web browsers. And someone has created a nifty R library that takes three.js and allows you to put your data into a nice visualization and allow you to explore it in a very simple way. Today, while there are various functions within three.js that can get pretty complicated, like 3D globes and 3D scatter plots, we're just going to focus on building a 3D scatter plot. And it's moving on its own because it's just a recorded GIF, just for your reference. So just to get started, it'll be good if you haven't installed it already, install three.js using option 2 on the screen. And then we're going to load in three.js. Okay. Well, if you haven't installed it already, I'm just going to just type this in, three.js. Sure. And I'm typing three.js. Loads up nice and simple. And we're going to then explore the syntax for the scatterplot 3.js function. There are a number of parameters that you can add to make your visualization pretty. X, Y, Z are your parameters, the variables that are going to be put into a 3D scatterplot. We have axis labels that can make things even prettier. You can specify the color of the points. You can specify the size of each point, the label, so you can have a little pop-up labeling feature that, so when you scroll over a given point, it'll tell you what it is, and a bunch of other things. And we'll just build out this visualization nice and simple from the ground up. So the first thing is to run this rudimentary plot. So we're going to type in scatterplot 3.js, parentheses, and then we're going to call three variables from the data frame that you've already loaded in. Data $emp status, comma, data $PCT underscore poverty, and data $HS underscore grad. So I'm just going to be a little lazy and just copy this in. and you can run it. And on the right, we should have a nice 3D plot, nice and simple, and not exactly the prettiest one, a little bit of a blob. And click on this little button over here that will show this in a new window. So this is really, in fact, a fully operational visual. And you can see that the points kind of move up, have like a sort of positive, a direct relationship. There is some sort of correlation going on. Great. Any questions so far? Okay, so let's make this a little bit prettier. And like any good analyst, you want to label your axes. And one thing about labeling in three.js is the order is a little funky. So while we have we put an x, y, and z as the first three parameters, the axis labels are ordered x, z, y. I know. It's all sorts of funny, but it's helpful to know that. So we're going to just add these simple labels onto our visual. You can label them anything you want, but I'm going to copy this and just paste it in, and I'm going to save it up here so you have. And so you can see now high school degree up on top, unemployment to the bottom right, and poverty to the bottom left. So this is still not giving us the really nice and juicy stuff. We'll get there. Now, like you notice those plot points, they're really kind of fuzzy. They're not really pretty. You can't really distinguish one point from another. It's just a mess of points. So we can change the quality, and we can use different functions to change the style of those points so that it actually looks like something. So we're going to use the renderer parameter to state which package we should be using to render the plot. So we're going to use renderer equals canvas. And I'm just going to run it here. I'm going to just add renderer equals canvas. And you're going to see something magical. It's pretty automagical. All of a sudden now these random mess of points now turn into little circles, little points with a bit of stroke around them, so you can see, I see some definition. And so there's a very strong center mass, indicating that there's some interesting patterns that are locked in there. Sure. So renderer is just so without renderer, without specifying what rendering engine you should use, you'll end up with the messy plot. So we'll have this version. By specifying canvas, it'll make three.js turn each point into a little circle with a dark line outline around it, so that you can see more definition. There are a number of other options. There's auto and there's WebGL, and those are different options that you can find in the documentation for the three.js package. Great. So now we're going to add some color to this by using the flip dot y equals false. We can flip the y-axis around, because right now if we take a look at the plot, we can see that if we rotate the plot over here, everything the unemployment axis and the high school degree axis, they're ascending from 0, but poverty rate is starting from the max value. So we want to flip that around so everything is uniform. We want to also change the colors a little bit. This type of blue is nice and all, but I think we all have our own color preferences, so we can switch it up a little bit. And we can also change the size of the dots. And so when you change the size of the dots, you can see more clearly into the interior of that mass of points. So let's go back to R and just take a swing at it. So we're going to add, first I'm going to just add the flip.y equals false. We're going to change the size equals 0.5. You can make that anything you want, but anything greater than 0 and less than 1. And then we're going to also change the color. And so the color option is call equals, and then, I don't know, let's put in red. And I'm going to just copy that and run it. And now we get a plot with red points. The points are a lot smaller. And the important thing here is that when we look at the plot, the poverty rate starts with the lowest value, not the highest value. So now everything is oriented from the same origin. Great. Now, I think it's kind of important for us to be able to see what each of those points are. So if we look at this plot, like we don't really have much context. Question? Oh, there's a question?
Is there a way to make those each bubble a little more transparent so you can see this into the center?
I believe so. So we can use the, I think, opacity function. So if I were to type in, oh, that's not working. Let's just, yes. Rather than wasting time, I'll get back to you on that one. But if we look at the three.js help section, we can find various options for changing all the different stylistic functions. Question. Can you speak into the microphone, please?
If we wanted to color the dots according to the state, how would we do that?
We will get to that in a little bit.
Okay.
But we're going to do it by region, because I think if we were to use state, I think the graph would give people seizures. We want to minimize the number of colors. Great. So the next thing is to add the labels to the region. So nice and simple. There's the labels option, and we're going to use the variable region name. And we're going to run this. And so now every time you scroll over something, you'll have the region label pop up, which is quite nifty. But it's still not telling you everything that you would want to know. You would want to see how different regions are colored, so you can see the clustering across these three variables. So that's where we're going to rely on some other features. Actually, just take like a quick moment to assess what we have here. So when we look at education versus poverty rate, we see that there is an inverse relationship, and that's pretty intuitive. More education, less poverty rate. I'm not talking about the direct I mean, more education, less poverty rate, and then vice versa. And I'm not saying that there's a causal relationship here, but it's just what the graph is showing. Let's say we rotate it to looking at high school, the education versus unemployment. There's a little bit of a downward slope, but it's largely a mess. There's not likely a very strong relationship there. And then let's continue to rotate. Let's say we rotate this way, so that we're looking at poverty rate versus unemployment. There is a positive relationship between the poverty rate and unemployment. So there's some basic graphs, basic relationships that can be determined using the 3D plot. Well, we can do far more. So if we add the colors, we can get into much more detail. We can infer a lot more. And we're going to use the regions as a way to color the points. And now we're going to have a whole bunch of functions. So first, let's interrogate the region variable. So in R, I'm just going to type in unique data and then region. And we have 4 unique variable values, 1 to 4. We're going to look at region name, and with 4 basic regions that align with the Census Bureau's classifications. And in order to label each region, each point by its region using color, there's something interesting about the color function. So before we typed in call equals 1 color, and basically assigns that color to every point. If we provide three.js with a column that corresponds to that has a row, a color corresponding to every single point, we can render any color for any point in the data set. So we're going to go back and just create a new variable in the data frame for the data frame, and we're going to label enter these hex codes. And I'm going to give you a couple of moments to do that. You can either choose those hex codes, or you can just type in something simpler. So for instance, I'm just going to run through these. So data, $sign colors. So first I'm going to create a blank variable. And then you might have learned this in an earlier R class, but now we're going to fill in the blanks, literally, based on conditions. So we're going to look at data, and we're going to look at region 1. So, and we're assign a color, so I'm just going to say red. And so when we look at the data set, once we're done with this process, we'll have, for every single region 1 value, in the corresponding color column, there's going to be the word red. And then let me just go up the chain. So go to, maybe I'll make it blue, make the region 2 blue. Region 3, let's say yellow. And region 4, green. So now if we take a look at the data frame, so one of the things I love about R Studio is it gives you a nice browsing function. So we have here region, in the first row, region 3, that corresponds to yellow. Easy peasy. And then we go down a little farther, region 4, as we had, it should be green. So we go all the way across to the color column, and you have the word green. And region 3, we have yellow. So now we have like the basic ingredients to create, to start to differentiate clusters of points. It's also important now that now that we've labeled everything, we want the colors to we want to resort the data. So if you we can use this nifty command to sort the data, and that's important because it determines the order in which points will be rendered in the graph. So we'll put the lower number regions up top and then the higher region numbers down below. So I'm going to take this from that. And now we're just going to replace the red in our code up here with data color. And we're going to run it and see what happens. And now we have this cool three-dimensional graph that has each of the regions labeled colored in. We can see that up here, let's see, the blue, this is the Midwest region. Down here we have the South, so we can see some differences in the education to poverty relationship. And let's say we start to rotate it. So on the back we see some points for the Northeast. It's kind of buried in there. Still can't get full visibility of the interior, so we can change the size of the points to get a better view. So let's do a quick exercise. So just to get familiarized with that code, if you can adjust the size option. So right now it's 0.5. If you make it 0.2, you can make the points a little smaller. Play with that a little bit. And then I would say substitute the emp status variable with this specific variable. So taking the number of households with a log transformation to it and see how it changes the clustering. Okay. Well, let's just do this together. So first, now you have this code nice and neatly written out. You can do a lot with this. So let's say we change the size to 0.1, and we run this. And I'm just going to press Control Return. Now the plot the shape is relatively retained. You get now you can see into the middle, and you can see that there's some interesting clusters of activity going on. There's some hidden colors, like red is in there, buried in there, and that's I believe the Northeast. Now let's change the emp status to households, and we're going to use a log transformation to make sure that the household number is kind of compact. Just as a review of what households does, I'm going to use the hist function below just to show you what the distribution of this data looks like. And so what you can see is that there's a very large peak to the left, meaning there are a lot of records, county records that have very few households, and they have some that go really out to the right. We use the logarithm, natural log function. We compress, we pull out those low values towards more of a normal distribution. So this will make the graph look a little bit better. So run this, and then I'm going to change the size back to 0.4 because it'll be a little bit easier to see. So now we can see that there's been, on the unemployment axis, which is now just number of households, the distribution gets pulled out to the right. So we compare this to what we had before. It's a bit of a quite a bit of a difference. And you can see some differences in the points, the clustering of the points. Great. Any questions?
You said it was very important to sort. Why was it important to sort?
It changes the order in which points are rendered.
Why is that important?
Sometimes it'll, if 2 points have very similar, very similar values, they'll be very close to each other in the graph, and you might, the point that is farther out in front will get priority. Farther up the list will get priority. In this case, we wanted to show, in testing the code, we found that sometimes if you don't sort, 2 points that are supposed to occupy relatively the same spot, these are like imprecise locations in the scatter plot. The one that came in first in the list gets rendered a little bit more clearly. Yeah, and also you have to play with the colors a little bit to really get a handle of it. All right, so we're going to move on to the next section and largely focus on maps, because oftentimes graphs are not really...
I still have a question on 3.js. Is there a way, you mentioned that 3.js is a JavaScript library.
Mm-hmm.
Is there a way to convert what you have done in R or RStudio into JavaScript code?
Basically what happens, so there are various ways to do that, but the main method is going to be using something called R Markdown. And R Markdown allows you to take your results, whether it's a static graph or a JavaScript visualization, and knit it or convert it into an HTML web page. So we'll cover that at the very end. Great. So we're going to cover maps. So oftentimes graphs don't really get the full point across. There's a nice organic feel to some maps. Sometimes they do get overused, but they have a lot of potential value. So I'm going to give you a very short crash course on geographic information systems, so GIS. GIS, it's the discipline that creates all the maps, all the web maps, how to do the processing of data so that it's useful for geographic analysis, spatial analysis. And in GIS, there are various types of data, but the type of data that we're going to work with today is called a shapefile or a vector file. Shapefiles are not just one file, they're a collection of files. And so over here, to the left, I have a screen cap of a shapefile that was provided for this exercise. And there are a whole lot of files in there. But the 3 files that are necessary for any GIS project are .shp, .dbf, and .shx. .shp dictates the geometry, so the shape, the shape of the information that is being put onto a canvas or a map. .dbf contains the data. So for every single census tract or county, what values are associated with that census tract. .shx is a shape index, a positional index, so indicating the priority of data elements. The process for GIS, the shapefiles can be used for 3 principal types of information. We have points, so you have lat long, you have polygon, so it could be like a county shapefile, it can be a house parcel, tax lot parcel, in lines. So like a lot of streets are represented by just polylines. And the workflow is pretty simple. We import a shapefile into R. We import some data that we want to merge onto the shapefile. Oftentimes, the shapefile contains basic geometry information, but doesn't contain the data that you want. So we're going to then, in step 2, join the data to the shapefile so that we can render it as a leaflet map. Leaflet is another JavaScript library that allows you to create web maps. And it's a pretty amazing library. It's open, it's free. Star and I use it all the time for our work at the data service. And you can go from a data set to map functionality in minutes once you get used to it. So if you haven't already, it would be great if you could install these 3 packages and load them up. Leaflet is, again, the web map package. RGDAL is our library that is based on the GDAL geographic information like manipulation library, and that's necessary to read shapefiles. And since we're going to merge 2 data sets, we need to do a little bit of formatting, and I'll cover that in a little bit, but we'll use the stringer package. Great, so I'm just going to quickly include from that. So our leaflet, our GDAL, which has a lot of, okay, and stringer. So now we don't have to worry about those down the road. And now we're going to read in shapefiles. So if you've loaded in your data before, and you had set a working directory for part 2 of the session, running this shouldn't be too tough. Basically, the syntax is read OGR is a function to just read a shapefile. We're in our folder. We have the class materials folder. We have an SHP folder named SHP. And so in our syntax, we're going to do SHP/. So it's going to say, like, look, since you've already set the working directory, we're going to look in folder SHP/, and then we're going to look for this file. And then there's a comma over here, and then we're going to run this as well. So this is saying look for this file, and we're going to call it this. And then that's the base amount of information to assign a shapefile to this object called SHP. And then we're going to go ahead and run that in the leaflet functions. So leaflet command this is the bare minimum that you would need to render any map. Data equals SHP. We're going to do $, greater than $, and then add polygons. And so when we add polygons and say that we're going to make them blue, we're going to add a color to each of the counties in this data set. So I'm going to go ahead and run this, and I'm going to include it up here so you can take a look at it while I just run this, and bam. Cool. So we have this like kind of unsightly map. It kind of hasn't really been refined enough yet, but you can see that we are rendering a web map. Really, basically looking at the U.S. completely flattened out from afar, and you can zoom in, zoom out, and each of the polygons is colored in with a blue. All right, So the next thing is we're going to just start to stylize the polygons so that they look a little bit prettier, using the fill opacity function to, change the transparency. So the values between 0 and 1. We're going to make the borders white, and we're going to change the weight. So I'm going to add that to this function here. And we're going to run it. And hopefully it's going to finish. So now it looks a lot cleaner. Like we have, you can start to see a little bit more definition. But it's still not sufficiently neat. So now we're going to add in something called a tile, a web map tile. So there are a number of GIS providers, companies out there that produce web map tiles. So the imagery of the Earth, the pictures of the Earth that you see in Google Maps or in various web map apps. CartoDB is an awesome open provider of this. So we're going to use the positron web map tile, and I'm just going to go and add this here. And so now when I re-render it, we have a base map in the background. And actually, cool thing is if you zoom in, it has a lot of pre-cached imagery tiles so that you can go all the way down to your home address if you want. Any questions so far?
I'm not sure what the tiles provided. The shape file, when you added it in, brought in the polygons, but what did the additional tiles provide?
Can you repeat?
Okay, the shape files are the actual, the shape of the U.S., right? And so it's basically the geometry of the map.
Mm-hmm.
But what did actually the provider tiles provide? It provided the rest of the world. But
yes, so the provider tiles provide the base map. So base map is everything that is, so the vector file, let me see, maybe go back one. So this is what the map looks like without a base map. It's just a gray expanse with a number of polygons in the middle, which represent the US. When we add in the provider tiles, we provide more context. The picture that, like the canvas that you can understand where is the US in the world. So without that, without adding provider tiles to your function, you can't really have a well-rounded map.
Could you zoom in on where you drew all the county outlines on the U.S.? Will we be able to zoom way down to our home address? Because that's where I live in the U.S.
Yeah, I guess. Well, first we'll recenter the imagery in a second. But I think just for good practice, the convention for most web maps is to have some base tile layer, because otherwise it looks like a graph. The goal is to provide a web mapping experience, not just a 3D environment. Sorry.
Can you show the read OGR statement again?
Sure. So it's up here. So the read OGR statement, so it starts off here, since we've set the working directory, so I'm going to just pull it up here. So my working directory is set to class materials, that's the folder. There's a folder within class materials called SHP. So the first thing at the gate is going to be SHP/, and that indicates that we're looking in a given folder, and within that folder we have the following shapefile. So the shapefile name is quite long, but you'll notice that the end is .shp. So we're going to look in this folder called SHP/ get the shapefile, and then it's going to call the layer, look for the layer, all the files that start with the CB _ 2014 _ US County _ 20M, and pull all that information into that SHP file that we're assigning it to. You cannot, what? Did you set your working directory? Yeah, I'll take a look after a bit later. I'll check in a little bit. Okay, so now we're going to center the tiles. So as someone had mentioned before, it'd be just good to look at at where we are in the U.S. So we're going to use the set view options. So LNG here is the longitude, LAT is the latitude, and zoom is the level. So the zoom level goes between 1 and I think 15 or 20, and that sets how high you're looking at the U.S. from. So I'm going to just drop this into the code. And so we can see a nice map centered around the U.S. Now what we really want is to get to like all the coloration. And so we're going to do a couple of other things to bring together data sets. So we're going to skip the 10-minute break because there's a lot of material to be covered here. So we're just going to pound right through it. So now we're at a point where we've imported a shapefile, we imported data. We have a basic outline of what we want to get to. Now we have to join data sets together. So remember how we had the data frame from before? So we can check the columns, the column names, and the formats. So if we go back to R and we type in str data, this will tell us what the various variables look like within that data frame. And then we can also do the same for the shapefile. So we do str shp. And there's some weird, some funky syntax with the data file, the shapefile. So we have to call shp at data, and run the same thing. So since shp has so many different files connected to it, so we have like the geometry, the data, the spatial indexes. We have to be very specific as to which part of the file we're looking at. So we're looking right now at the data part. So in order to join the shapefile and the data file, we need a key, a primary key, to join between the two data sets. And so in this case, and the data data set, it's ID2, and that should represent a US FEPS code, and the SHP file should be GeoID. Now you can notice you'll notice that they're in different formats. So if we notice that in the SHP file, everything is a factor with a padded 0 in front of the values. So there should always be 5 characters. But if we go over to the data frame, ID2 is all integers. So we're missing a padded 0. So this is what we have to fix before we can merge. So to do that, we're going to use some functions that we got from Stringer, that library that we had loaded up earlier. And we're going to use the str_pad function. So since we're going to use the data ID2 variable, we're going to first convert it into a character, a string, so as that character. So in order to pad zeros, you have to first convert a variable into a string. Within str_pad, we can specify the number of spaces that there should be, the number of characters there should be in a given piece of data, and then indicate what goes in front. So I'm going to just do a quick, very, very, very quick demonstration. So let's say we have this str pad, and let's say I have a string that contains 1, 2, 3, 4. If I do run this, it'll put a 0 in front. So now, it'll put a 0 in front. And so this is basically what we're going to do to the data ID2 variable, and we're going to create a new variable from it called GeoID. On the SHP side, we don't really need to add a padded 0 because it's already a character, or it's already a factor. We just have to convert it into the same format. So str_pad above spits out a string value, a 5-character string value. Here we're going to just, it already has a 5-character string value. It just needs to be converted into a string. We're going to reassign it back to GeoID within the shapefile. And then down below, we're just going to merge. So now I'm just going to grab all of this, and I'm going to paste it into the code editor above so you can just follow along. And when we just run this, no errors got kicked back. If I take a look at SHP data, we now see that there are a couple of new features that have been added. So like the geography, the percent poverty, among other things. And this is all bad. I don't know why my console is bouncing around, but please bear with me. All right. So now we have all the pieces together. We can now create some even prettier maps. In order to color a graph, a map, we need to specify the color schema. So there's something called color quantile, and it's a function that specifies the color code. So in this case, one of the color codes that's available is yellow-green, YLGN. Null is we just put it there as a way to it's expecting a certain value, but we're just going to ignore that for now, and we're going to specify n equals 30. So this is 30 buckets of color. So for a given value, given variable like poverty, we're going to break poverty into 30 buckets and assign each bucket a color. So I'm going to take that, dump it into our code editor. Nothing should happen yet. We're going to get to the fun stuff in a second. So YLGN, capital Y, lowercase l, capital G, lowercase n. That's a color spectrum, a color palette for those who just asked via WebEx. All right, and now we have this magnificent piece of code. Since we've already written out the first part, all we have to do is replace fill color, which was previously blue, with this function. So palette, so as we have done before, palette is the color palette. It accepts a variable from the data set that we've put in to Leaflet and converts that value into 30 buckets, as we have specified before, and for each of the buckets, there's a color. So we take that, go back to, so I'm just going to run fill color. When we, when we run that, we should get a nice map. And there are a lot of other functions that we could use. So, for instance, we could add little pop-ups, which I'm not going to cover because that's just those are fine details. We can add toggles for different series that you would want to compare against one another. If you start to use Leaflet in the JavaScript version, you can have synchronized maps. So imagine 5 or 6 maps on one screen, and you could scroll around, and the map recenters based on where you scroll in one of the panes. So there's a lot of possibilities. I think the Leaflet option, the Leaflet library in R is just the starting point. Great. Any questions?
Back to the underlying map, can you get to the detail by somehow making the transparency different?
Yeah, absolutely. So we can change the fill opacity and the add polygons options. So let's say I changed it to 0.3 or 0.2. So closer to 0 means like greater transparency. And so we have a much lighter, oops, we have a much lighter version of the US, and we can zoom in more. And if you wanted to go all the way down to the district, sure.
Okay, I was just going to ask what, if you could go back to the why you put the null value in there for the color palette.
So this piece right here. So a color quantile is the function, and it accepts like the two things that we're concerned about in this session are this string here and this piece here. So you can, basically. So there are a number of different color spectrums that we can use. So let's say we wanted to use RDBU, I think it's red blue. That's it. And then we wanted to change the number of buckets. So maybe we can make a 3-bucket map. You can run that, and then run the code again, and it should render a red-blue map with only 3 buckets. let's say we want to make it, and maybe we'll just change the opacity because this way we can see a little better. Let's say we want to make it 100 bucket maps to get finer gradation across the various values of poverty. We get like this finer gradation because it'll look for 100 different buckets and then assign every single county to one of those buckets. Yeah.
So what is palette and what is the tilde in front of it for?
So palette is so call quantile creates a function, like a wrapper, that will accept any value and turn it into, assign the right colors to each of the values in that distribution. Palette is the custom function that we've created.
And then what's the tilde operator for?
Can you repeat that?
What's the tilde operator for in the add polygon call?
To be honest, I don't quite know, but
Okay.
it's just part of it just runs better when I have that there.
Okay, thank you.
Any other questions? Have I ever mentioned, or has anyone ever mentioned that R is a funky programming language? R is a very funky programming language. It's very peculiar. Great. Well, so the next portion, we're going to just cover something very basic. Going back to one of our participants' questions about how to take some of the stuff that you've produced in R and render it as like a JavaScript visualization or what have you. So that's where we can use R Markdown. And R Markdown converts R script, the visualizations, everything into a static HTML web page. And to do that, we need to install the knitter library. So like try and install that now. Right. We will get to that in a sec. So now in RStudio, we're going to go up to the top left, click on the R Markdown button, and you'll get prompted to create a title for this. So let's call it CDA demo, and your name goes there. Great. Well, the cool thing is that we can actually just take, we can use this to tell a story, like really write down everything you've done in a transparent manner. Up here, this is where you write just standard text. This uses a format called Markdown. So if I want to have a header, you can write down a nice narrative there. And here we'll have, you can put in basic code, and this will get rendered. And then below, if you put something called the echo equals false option at the beginning of this code section, like this gray section, we can just embed whatever is in, embed the results of whatever's in the code section. Each code section is denoted by these three dashes, tildes? Yeah, it's not exactly backward slash or tilde, but backquote. And then curly brackets are, and then close out with the three backquotes down below. And if we just go up here and click on knit HTML, first we'll probably have to save this. So we'll save the R Markdown file, and now it's going to render everything in the code in HTML format. We can open this up in a browser like Chrome, and you can see everything in a static form. Now, if we go back and we can do some fun stuff with this. We've put all this code together to show off what we can do with this data. So let's say we
We have a question. We have a question from WebEx. How do you open the R Markdown again?
So you go up to the top left, where there's a plus button, top left of the R Studio page. Click on that little button. Second option is the R Markdown file. You click on it. It'll come up with gives you opportunity to label the title and your name, and then press OK. And now you have this shell that you could write everything. You can include your code in. And then when you want to run, you just click on the knit HTML button. It'll prompt you to save the Markdown file, and then it'll run it, and it'll render this HTML file. And actually, if you look at your folder where you saved your Markdown file, there will be an HTML file ready to go. So you can use that. You can go back and run the static web page whenever you want. So let's say so we can take some of the code that we've written before. So we have we had set up some basic code before to look at the social and economic data. So I'm just going to take that and I'm just going to paste it in to where it says summary cars in one of my Markdown files. And I'm going to just write some commentary like, and then we're going to run it. So this is actually a good thing that we got this error. So the thing is that when you run any of your code in Markdown, you have to include basically the full script. So which libraries you're going to use, which paths, like working directories, you're going to pull the data from. You have to read in all the data. So basically it creates a virtual machine to run the script and then use that information to render. So we're going to have to include the three.js library in the code. And you can run it now. Should take only a few seconds. And now we have an HTML file with the visualization that was executed using that code. And actually, one of the initiatives that Star and I co-run called the Commerce Data Usability Project, whenever we have an R tutorial that we write, we focus on producing long-form tutorials that show how to get started with different programming languages, whether it's Python or R. Every time we publish one of these tutorials, we use this as the medium, because you can see the results of the code, and you can interact with the code in a way that makes sense. So perhaps it would be good at this point to see. I'll let you take a crack at playing with that Markdown. We have a little bit of an exercise where I want you to execute. I want you to play with what happens when you change the curly bracket R section with these different parameters. Maybe if you have your code ready from the previous section, the three.js section, dump it into the code section in the Markdown to see what happens. my notes? Oh yeah, absolutely. And actually, if you go to the CDA, if you go to this GitHub page that I think Star might have sent around, there's a GitHub page that contains a step-by-step.
We'll send out the link to the Markdown file too at the end after class with all the other materials.
And actually, the color spectrum, the color palettes that are used are a little prettier, I think, in the examples online.
I'm sorry, could you say that in the microphone again?
How is this different than a Jupyter notebook?
So Jupyter notebooks, so it's similar. The thing is, interesting thing about Jupyter notebooks is that you can also install an R VM R kernel to do the same thing. So Jupyter is a little bit more flexible. R Markdown is specific to just R.
The difference really is the Jupyter runs the R kernel in the background, or a Python kernel in the background, and so you run the live code. This is knitting an HTML page final that doesn't require the actual underlying code, again, for it to be active.
For the folks on the line, we're going to give you another 3-4 minutes to play around with the different options. And then just open it up to just general questions.
Alice. And then you use the red, blue.
Sure.
Get it.
So the red palette. So there was a question about red palettes.
Oh, that's it. Okay. So you just increase the n to 100 to make.
Number of buckets increases the number of buckets. N equals 100 means like there's 100 buckets.
Okay. I was just wondering if you had the middle part where it says null. What does that control?
I think that's where the value goes. So like if you go %poverty, it'll get dumped in there once you create a little function for it. So right now it's null just to accept anything. So we can change some %poverty to and status. Sure. So I think that really just concludes today's session. We just want to say that so when thinking about visualizations, there is a temptation to focus on very complex visuals, rely on visuals as a way to compensate for substance. Keeping it short and sweet will maximize the chance that you'll get your point across. Their visualizations are really much a tool for telling the story. And as like Star outlined earlier on the presentation, like if you start to find that there are things in your visualizations, you have dashboards, what have you, that don't have a clear meaning, a clear interpretation to it, leave it out. You should only put stuff in that can be distilled down. It depends on the nature of your conversation, whether it's like a little bit more exploratory or telling a specific point. It's really up to you. There are tons and tons and tons of other libraries out there, so I just want to point out htmlwidgets.org. And this site is a growing repository of various libraries that are available for visualization. A lot of them have very similar flavors, so like Plotly, Bokeh, HighCharter, they have very similar offerings with slightly different interactivity. There are a number of network visualization libraries out there that are pretty darn neat. Of course, we have the data tables library that Star showed you. I showed you a little bit about the three.js library. This is yet another three-dimensional library. And that's just a showcase. There are a number of other libraries that are coming online. When this site was launched, there were only 5 things on there about a year ago, and this is just growing. So the possibilities are growing. And with that, thank you very much.
We'll be here for a few minutes if you have any questions or any follow-up. If you're here in person, please make sure to fill out the sign-up sheet that our lovely coworker, Pam, is holding up. If you're on WebEx, I want to thank you. We will send out the recording for this and for the data analysis as soon as we have it. And we will send out an email with all the markdown and all the additional data files and where they are if you didn't get a chance to do it before the class. Thank you very much.